We're given f of x comma y equals e raised to the power of 2x times sine 3y. We're asked to determine the gradient of f at the point 2 comma negative 2. This is also referred to as del f. So for a quick review, if we're given a function f of x comma y and the partial derivatives exist, then the gradient of f of x comma y is the vectored valued function, where the x component is the partial of f with respect to x, and the y component is the partial of f with respect to y. So we'll first find the gradient of f in terms of x and y, and then we'll perform substitution to find the two-dimensional vector at the point 2 comma negative 2. So again, we need to find the partial of f with respect to x, then the partial of f with respect to y. So the gradient of f would have an x component of, we want to differentiate e raised to the power of 2x sine 3y with respect to x, treating y as a constant. And because the derivative of e to the 2x with respect to x would be e to the 2x times 2, the partial with respect to x is going to be 2 e to the 2x times sine 3y. Now we need to find the partial of f with respect to y, so we differentiate e to the 2x sine 3y with respect to y, now treating x as a constant. And the derivative of sine 3y with respect to y would be cosine 3y times 3, and therefore the partial with respect to y would be 3 e to the 2x cosine 3y. Now we need to evaluate this at the point 2 comma negative 2, so we substitute 2 for x and negative 2 for y. So the x component would be 2 e to the power of 2 times 2 times sine of 3 times negative 2. The y component would be 3 e to the, again, 2 times 2 times cosine of 3 times negative 2. Let's go ahead and simplify this, and then we'll use the calculator to evaluate it. So we have 2 times e to the 4th times sine of negative 6, and here we have 3 e to the 4th times cosine negative 6. And now we'll go to the calculator to get decimal approximations for the x and y components. And now we'll go to the calculator to get decimal approximations for the x and y components of our two-dimensional vector. We first need to make sure we're in radian mode, so we'll press the mode key. Notice how radian is highlighted, so go back to the home screen. And now we'll enter 2. And then for e, we can press second natural log, which brings up e raised to the power of. We have e to the 4th, right arrow, and we have times sine of negative 6. So negative 6, close parenthesis, and enter. So the x component is approximately, let's say, 30.5111. And now let's find the y component. So we have 3, second natural log for e raised to the power of. Again, the exponent is 4, right arrow, and then times cosine negative 6, close parenthesis, and enter. So to 4 decimal places, the y component would be 157.2706. Let's go ahead and write these down. So now that we have the gradient of f at the point 2 comma negative 2, let's review what this means. Remember, f of x comma y would define a surface, and we just found the gradient at the point 2 comma negative 2, which tells us the direction of maximum increase of f is given by the gradient of f at the point x comma y. So we just found the direction of maximum increase of our function at the point 2 comma negative 2. It's also true that the maximum value of the directional derivative of f at that point, or the rate of increase, is equal to the magnitude of the gradient at the point x comma y. I hope you found this helpful.